Yes, both scenarios described are in violation of the National Electrical Code, specifically NEC Section 225.35c, which dictates that a delta-connected service must be connected to a delta-connected panel, while a single-phase service must be connected to a single-phase panel. The first scenario, involving separate breakers feeding the alternating current unit's three phases, with a two-pole breaker for two phases and a single-pole breaker for the high leg, and the second scenario involving a three-pole breaker with a side terminal for the high leg in a single-phase panel, both represent deviations from this requirement. Regarding the Bryant breaker with a side terminal, Bryant did manufacture a three-pole circuit breaker with a side terminal for connecting the high leg. However, these breakers are obsolete and are no longer manufactured. To correct these violations, there are a couple of options. Firstly, rewiring and installing a three-phase panel. This involves removing the single-phase panel and installing a new three-phase panel along with appropriate breakers. This option is the most expensive but also the most compliant with the NEC. Secondly, using a phase converter. A phase converter can convert a single-phase feed into a three-phase power supply. This option is less expensive but requires proper installation and diligent maintenance. If rewiring is not immediately feasible, a temporary solution may involve installing a three-pole disconnect switch downstream of the single-phase panel. This allows for the safe connection of the three-phase equipment, but it is not a permanent solution and does not fully comply with the NEC. It is crucial to always consult with a qualified electrician before making any modifications to electrical systems. Improper installations or repairs can be hazardous and pose safety risks. It's important to delve deeper into the NEC regulations governing electrical installations to fully understand the implications of these violations. Section 225.35c is quite clear in its requirement to match the service type with the panel type. Using a delta service with a single-phase panel creates an imbalance and can lead to operational problems for the connected equipment. Let's talk about the rewiring option in more detail. When replacing the single-phase panel with a three-phase panel, it's not just a matter of swapping out the panels. Firstly, the entire wiring system needs to be assessed to ensure it can handle the three-phase load. Secondly, the neutral wiring may need to be upgraded. Thirdly, the grounding system needs to be checked to ensure it is adequate for the new panel. Fourthly, you'll need to install three-phase breakers that are appropriately sized for the loads they will be serving. Fifthly, the high leg, also known as the stinger leg, needs to be clearly identified and marked in the panel to prevent accidental connections to 120-volt circuits. It's crucial to use proper labeling and color coding to ensure that anyone working on the system in the future is aware of the high leg's presence. Moving on to phase converters, there are different types available, including rotary phase converters and static phase converters. Rotary phase converters are generally more efficient and can handle larger loads, but they are also more expensive and require more maintenance. Static phase converters are less expensive but may not be suitable for all types of three-phase equipment. They typically provide reduced torque for motor applications. When selecting a phase converter, it's essential to choose one that is properly sized for the load it will be serving. It's also important to follow the manufacturer's instructions carefully during installation to ensure that the converter operates safely and reliably. The temporary solution involving a three-pole disconnect switch offers a means of isolating the three-phase equipment for maintenance or repairs, but it doesn't address the underlying code violation. The disconnect switch should be rated for the voltage and current of the three-phase circuit, and it should be installed in a readily accessible location. While this temporary fix allows for safer operation of the equipment, it doesn't provide overcurrent protection for each phase, which is a fundamental requirement of the NEC. It's important to remember that electrical systems are complex and can be dangerous if not handled properly. If you're not comfortable working with electricity, it's always best to call a qualified electrician. An electrician has the knowledge, skills, and tools necessary to safely and effectively install, repair, and maintain electrical systems. Furthermore, electricians are familiar with the NEC and can ensure that all work is performed in compliance with applicable codes and regulations. When dealing with the high-leg delta system, safety precautions are paramount. The high leg typically has a voltage of approximately 208 volts to ground, which can be dangerous if touched. It's essential to use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses, when working on or near the high leg. Additionally, the area around the electrical panel should be kept clear of obstructions to prevent accidental contact with live parts. Regular inspections of electrical systems are crucial for identifying potential problems before they become hazardous. Look for signs of damage, such as cracked or frayed wires, loose connections, and corroded components. If you notice any problems, have them repaired immediately by a qualified electrician. In addition to the specific code violation discussed, there may be other code violations present in the installations described. For instance, the wiring methods used may not be in compliance with the NEC, or the grounding system may not be properly installed. An electrician can perform a thorough inspection of the entire electrical system to identify and correct any code violations. When selecting an electrician, it's important to choose one that is licensed and insured. A licensed electrician has met the requirements set by the state or local jurisdiction and has demonstrated competence in electrical work. An insured electrician has liability insurance that will protect you in the event of an accident or injury. Always ask for references and check the electrician's online reviews before hiring them. A reputable electrician will be happy to provide you with references and will have positive reviews from previous customers. Remember, electrical safety is not something to take lightly. It's essential to take the necessary precautions to protect yourself and others from electrical hazards. Consulting with a qualified electrician is the best way to ensure that your electrical system is safe, reliable, and code compliant. Let's elaborate on the phase converter option, specifically the different types and their applications. Firstly, rotary phase converters use a motor generator set to create the third phase. They are generally more efficient and can handle inductive loads, making them suitable for powering motors, pumps, and other heavy-duty equipment. Secondly, static phase converters use capacitors and other components to create a pseudo-third phase. They are less expensive than rotary phase converters but typically provide reduced torque and are not suitable for all types of three-phase equipment. Thirdly, digital phase converters use solid-state electronics to create a precise and balanced three-phase output. They are more expensive than both rotary and static phase converters but offer superior performance and efficiency. When choosing a phase converter, it's essential to consider the specific requirements of the application. For example, if you need to power a large motor, a rotary or digital phase converter would be the best choice. If you only need to power a small load, a static phase converter may be sufficient. It's also important to consider the voltage and current requirements of the equipment being powered. The phase converter must be able to provide the correct voltage and current to ensure proper operation. Furthermore, the phase converter should be installed in a well-ventilated area to prevent overheating. The manufacturer's instructions should be followed carefully to ensure that the converter is installed correctly and operates safely. Proper maintenance is also essential for ensuring the long life and reliable operation of a phase converter. Regular inspections should be performed to check for loose connections, damaged components, and other potential problems. The converter should be cleaned regularly to remove dust and debris, and the bearings should be lubricated as needed. In summary, connecting a delta service to a single-phase panel is a code violation that can have serious consequences. It's important to correct these violations by rewiring the system, using a phase converter, or implementing a temporary solution such as a 3-pole disconnect switch. Always consult with a qualified electrician before making any changes to electrical systems. This will ensure that the work is performed safely and in compliance with applicable codes and regulations. Remember, electrical safety is paramount. Taking the necessary precautions to protect yourself and others from electrical hazards is always important. The initial scenarios presented highlighted potential safety issues and code violations. It's important to remember that the NEC is constantly evolving to address new technologies and safety concerns. Staying up to date with the latest code requirements is essential for all electricians and electrical contractors. There are many resources available to help electricians stay informed about the NEC, including training courses, online forums, and industry publications. Attending continuing education courses is a great way to learn about the latest code changes and best practices. Engaging with other electricians in online forums can provide valuable insights and help to troubleshoot complex problems. Subscribing to industry publications can keep you informed about new products, technologies, and code updates. When dealing with electrical installations, it's always best to err on the side of caution. If you're unsure about something, consult with a qualified electrician or electrical inspector. They can provide expert guidance and help to ensure that your installation is safe and code compliant. The consequences of improper electrical work can be severe, including electrical shock, fire, and property damage. Taking the time to do the job right is always worth it in the long run. Let's delve further into the specific NEC sections related to delta and single-phase service connections. Section 225.35c states explicitly that the type of connection must match the panel type. This is intended to prevent imbalances in the electrical system, which can lead to voltage fluctuations and equipment damage. Connecting a delta service to a single-phase panel creates an unbalanced load, as only two of the three phases are being used. This can cause the voltage in the unused phase to rise, potentially damaging equipment connected to that phase. Conversely, connecting a single-phase service to a three-phase panel can overload the single-phase conductors and create an imbalance in the three-phase system. This can lead to overheating of the conductors and premature failure of the electrical equipment. In addition to Section 225.35c, other NEC sections may also apply to the scenarios described. For example, Section 210.4 requires that multi-wire branch circuits supply only line-to-neutral loads. Connecting a line-to-line load to a multi-wire branch circuit can overload the neutral conductor and create a fire hazard. Section 310.15 outlines the requirements for conductor ampacity, which is the maximum current that a conductor can carry safely. It's essential to choose conductors that are appropriately sized for the loads they will be serving to prevent overheating and fire hazards. Section 250 provides detailed requirements for grounding and bonding, which are essential for electrical safety. Proper grounding and bonding help to prevent electrical shock and reduce the risk of fire. When working with electrical systems, it's crucial to understand and comply with all applicable NEC requirements. The NEC is a comprehensive set of rules and regulations that are designed to ensure the safety of electrical installations. Failure to comply with the NEC can have serious consequences, including fines, lawsuits, and even criminal charges. It's always best to consult with a qualified electrician to ensure that your electrical system is safe and code compliant. Remember that the information provided is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before making any changes to electrical systems. Safety first.